Hi everyone. In this short video, we'll walk through how to make high bandwidth noise and output ripple measurements on a power supply. The equipment that we'll be using today is a 2281S DC power supply and a battery simulator, but we will only be using the power supply mode, and the MSO5 series oscilloscope to take the measurements. What we have here is a direct BNC connection for optimal noise measurements. You can see just a BNC cable here connected to a banana adapter, and at the end of it I have another banana with a short in order to measure the baseline noise of the scope. So the settings on the scope is under channel 1 here. We want to make sure that we have the correct settings for this measurement. For coupling, we go to AC because we're interested in the AC measurement rather than the DC for the noise. Termination would be 1 mega ohm. Bandwidth limit, we want to go to 20 megahertz. And our vertical setting on the scope, this is nice, you could go down to 500 microvolt per division. Horizontal setting, we want to go to 10 millisecond per division. So you could see here, this is our baseline measurement here, and the measurements that we're interested in looking at is the RMS measurement for noise and the peak-to-peak measurement for ripple. So you can see in RMS we're around 100 microvolt baseline, and peak-to-peak we're about 700 microvolt. So this is a really low noise cabling scheme. Now we come to our power supply here. I said we're using a 2281S, and I have a 0.5 ohm shunt resistor as my load. See it, I have it connected here on the output, and so we'll make our connection banana cable here. I'll remove the short and we'll connect our scope connection here. Now I could easily set this power supply manually, or I could take advantage of our Kickstart software and set it from my PC here. Let's show you because Kickstart will also take measurements for us. So here I choose the power supply, and you can see here Kickstart will display readings when the power supply is on. So for my level, since I have a 0.5 ohm shunt, I'm going to do 1 volt, and I'm going to do 2 amps of current. So we'll be drawing 1 volt and 2 amps of current and a 0.5 ohm shunt. And I'll leave the rest of the settings, default settings, and we'll just go ahead and turn it on. And as soon as I turn it on, you could start see reading here in Kickstart, and we come to the power supply and it is on. And now we go to the scope, and you could see there's difference now from what we were seeing before to now. So so I could basically now increase my vertical scale since I'm clipping. So I go to 1 millivolt instead, and I want to keep my horizontal at 10 milliseconds. So this is your noise, is RMS here, and you have all these peaks here. So we could try and trigger on the peaks as close as we can. So I'm going to try to trigger on the peaks here in order to get as many peaks as I can, and I'll take a single trigger here, and you can see my noise measurement. I'm only at 360 microvolt, 66 microvolt RMS, and peak to peak is about 3.7 millivolt. In the data sheet, we spec this power supply to be below 1 millivolt RMS and below 6 millivolt peak to peak. This is a linear power supply that would give you really good output noise and ripple performance, and it'd be really good for your circuit design, so you don't have to worry about noise. And we could prove that here too. Really low noise and low peak to peak. Hope this short video helped you understand how to measure noise and output ripple. See you next time.